Okay, so this hour we are going to do a bit of an overview of Agile. This is an hour-long class. If anybody wants to talk, that's fine. All you have to do is let me know. I have default muted everybody because in a webinar of this size, then we're going to default mute. And if you want to talk, just send me a chat message or a question, and I will flip this back on. This is the Agile Primer. The time frame is from 11 to 12 Eastern Standard Time. My name is Kyle Griffin. And I started in the Agile movement sometime around the year 2000, right before the manifesto happened. And in 2001, the manifesto happened. Everybody got together and named this thing Agile. So we have a bit of a perspective here that is you won't necessarily get by talking to folks who've come in more recently. My focus is on the technical side of Agile. I've done lots of different parts of Agile, but my primary area of interest is on the technical side of Agile, which was mostly a forgotten discipline for the middle 15 years of that 17-year span. So, that said, let's talk about Agile. In theory, we were getting handouts going into the handouts section. Give me a sec and I will, we are trying to upload the files into the handouts section. It worked last time. We are having minor technical difficulties right now. Give me just a sec and I will see what I can do. Sorry, I got excited about fixing the problem, so I stopped talking. Okay, so I'm trying to upload the thing into a handout section. I have uploaded it into the handout section. This is a large chunk of what I'll be presenting, but as somebody with a lot of teaching and a lot of Agile experience, I may go off script kind of frequently because, well, when I write a presentation, I usually go off script about 10 minutes into the presentation. So that said, also, I'm going to make a quick check. Li Tai, you asked a question last time through. The question is, are you going to get credit for this? I put it through to my people. My people came back and said, yes. If you are in this session, you are going to be placed on the attendees list, and the attendees list is going to, for your organization, is going to be forwarded to your people. And so you will be credited for having been here. WebAge will send stuff to your people, and your people, I suppose, give you credit for this. I can guarantee that we are sending your people your attendance here. I can't tell you anything about your VZ credits, but I can tell you that your people will be notified that you are in these sessions. Okay, that's enough of the administrative work. Let's talk about Agile. So everybody starts off with Agile the same way. Basically, when you talk about Agile, the problem that people talk about is there's a lot of Agile projects that happen, and Agile projects that happen, the success rate, there are a lot of software projects that happen. And the core problem that we have is the success rate on software projects is weak. From Gartner and Standish and all of these folks, we look through and we say, okay, what's going on with software? And we find out that if you measure software success as by how many software projects come in roughly on time, roughly on budget, and roughly with the features that they asked for, you find out that the numbers stink, right? Somewhere on the order of a third of projects, and this third varies from a fifth to a third, really. Somewhere on the order of a third of software projects come in on time, on budget, and with the features that they were requested to do. Something on the order of half of all software projects come in, but they are substantially late or over budget, right? Or don't do what they were asked to do in the first place. And something on the order of another fifth or quarter of all projects end up being stopped before they stopped during the development phase. Honestly, most stopped software projects are stopped at the end after they don't work. So the core problem that we're trying to deal with is Agile is a lot of software projects don't work, and we're trying to figure that out. Second problem that we run into is when we build software projects, almost all software projects come in with, okay, here is the list of things I need the software project to do. Okay, great, so we have a list of things it needs to do. If I have a list of 100 features, how often are those features used? And I'm going to give everybody's easiest example here. So, how many folks use Microsoft Word? Probably 80%, 90% of you. Some of you just use Google Docs. Some of you use LibreOffice. I bounce back and forth. But we have Microsoft Word. How many of Microsoft Word's features do you use? If we arbitrarily start chopping Microsoft Word and say, okay, Microsoft Word has 1,000 things it can do. Yeah. If we use 50, Tatiana, if we use 50 of those features, if we use 5% of Microsoft Word's capabilities, and let's go beyond that. If I use Microsoft Word consistently for a year, what if I use more than 5% of Word's capabilities over the course of a given year? it's going to be surprising to me. I type, I center, I adjust the positioning of my text, I bold, italicize, underline, I change the paragraph spacing, I change the indents. I'm done. That's the only things I do with Microsoft Word. And Microsoft Word has 1,000 features. 1,000 features is honestly on the light side. It shouldn't surprise anybody that if a system has, on average, 100 features, half of those features, more or less, are never used, and another sixth of those features are used, again, once or twice in a year, right? And so we have the situation where when I write software, 20%-ish of the software I write constitutes almost the entire value of my software. And 2/3 of my software constitutes awfully close to 0% of my software value. That's crazy. If 20% of my work is about 95% of my value, and 66% of my work is roughly 1% of my value, maybe my energy is not going where it ought to go. Sure, perhaps Microsoft Word started off in a features race against WordPerfect, and so it had to do feature races. But for the 3 users who only use something that allows custom multi-language header and footers or something, I don't know. Most software has problems. Most software projects fail or don't deliver as they're supposed to. And most of the software projects that we build, even the ones that succeed, nobody uses most of it. That said, we need to do something. We need a fix to this approach to software. So Agile came about. I'm going to go slightly off script and give you the different ways of looking at Agile. Most people in the Agile world tend to look at Agile from one direction. There's actually several directions you can look at Agile from, and so I'm going to jump over and talk about other directions you can look at Agile from. So there's 4 different ways that I find useful to look at Agile. The first one is just historically. In the 1950s, people were writing software. We were discovering moths in our computers and calling them software bugs, and software was really hard and expensive to write. And the short version of what was going on in the 50s is when you wanted to write software, the economic realities of the situation were, get it right the first time, because if you make a mistake and you then have to make a change, changes to the software were incredibly expensive. I mean, we can talk about folks walking around and tripping with decks of 500 punch cards and taking more than a day to reorder all the punch cards. We can talk about the fact that the punch card printer machine was frequently not in the same room with the computer that executed the punch cards, and so the business of writing a program and the business of moving I have a really good question coming in, and I think I'm going to finish my short answer and then answer the question. Moving stuff from one room to the other. The fact that if you wrote software and it ran and it didn't run right, we didn't have debuggers compile, we didn't have much of anything. We would have to go ahead and read through the program without any real assistance and figure out what went wrong. And so the entire theory, correct theory, of software in the 50s and 60s was write our program, be very, very, very careful, and confirm that the program was correct before we put it in the system. So you gather your requirements and you do checks to see if your requirements, and we'd take an extra 3 days or 3 weeks to confirm that the requirements were right before moving on to program analysis and design. And everything was done carefully because the cost of making a mistake was enormous. Okay? That's historical. I'm going to pause and take my question now. Is Agile primarily a way of doing software projects, or does it handle other technical projects as well? That's a really good question. Agile was originally constructed as a method of solving software projects. So essentially, I need my computers to do something different than what they do right now by getting into the computers and in code or script typing stuff in. The primary focus of Agile is typing stuff into a computer to get it to work differently. There's a lot of energy in the modern world talking about Agile as a thing that can apply outside of software, but as somebody who's been in for a long time, I would like to suggest that I would like to suggest that there's other systems that do Agile or do Agile-like things that don't have all of the same things Agile says for outside of software. And so we need to talk about those. So yes, short answer is it's mostly about software. I can give you other stuff on the not software side. No, it's a great question, and it makes it more interesting when some folks have questions. Number two. Later, after the 50s, eventually we got C and UNIX. C and UNIX fundamentally changed what we could do in software, because anybody who knows Unix folks knows that the way we write software in Unix is I write 5 or 6 lines of software and then I execute it and see that it works. I confirm that this short bit works, and then I write another script that uses my first script. And so instead of getting maybe 500 lines, maybe 5,000 lines of code, and trying to make sure the entire thing is perfect. See, in Unix world, we write 5 lines of code, and then we say go. We check to see if it's working correctly, and then eventually we fix it and check again, fix, check, improve, expand. We run this very, very high feedback cycle based on the fact that I have tools now and I have a command line, and I can now run a fast feedback cycle instead of having to run a early perfection cycle. It fundamentally changed how software was written, and from the 70s you get the worlds that Eric Raymond likes to describe in his works, The Cathedral and the Bazaar. That was great. That was the 70s. By the mid-80s, things had changed again because the corporate world got invested in IT. So did the Department of Defense. And so what happened was in 1985, the Department of Defense released the Department of Defense Standard 2167A, which more or less said, hey, everybody's got to do Waterfall if you're going to get Department of Defense contracts. And exaggerating only mildly, Department of Defense contracts were like half of all IT work in the 80s. So that meant if you were doing IT in a consulting world, you had to do Waterfall. That makes sense. But then the people who were doing IT consulting transitioned into other roles as participants in the regular non-consulting industry, and they brought Waterfall with them. And so in the 80s, by the early 90s, everybody doing software was mostly, for large projects, doing Waterfall approaches. Interestingly, the original Waterfall paper is very simple. It says requirements, first you should do requirements, then you should do analysis, design, etc., 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 build and deploy, right? That's what the original Waterfall paper says. But turns out that's not what it says. The original Waterfall paper, Winston Royce, 1970, look it up, says get to build, this is for an ideal world, but it doesn't work in the real world. In the real world, you have to do the entire project once, then throw it all away, start over, gather requirements again, and go through the entire Waterfall cycle to deployment. If you don't do it twice, you cannot expect this to work in the real world. That's what the Waterfall paper says. But the graduate student who read the 1970 Waterfall Royce paper said, oh, this is the ideal model? Design, build, deploy? Okay, great. We're going to mandate that all projects must be done that way for the Department of Defense. And that was history. In the mid-90s, what happened is that stuff we saw at the very beginning where projects fail a lot and features aren't what people wanted mostly, aren't what people need. Well, we got into that, and a bunch of folks said, look, I'm following all the rules. I'm doing this Waterfall approach as good as is humanly possible, and it's not working. So let's try something else. And a bunch of people tried a bunch of different things, which eventually came to be known as Agile. Right? Really, a bunch of different people means there's people all over the country basically saying, this waterfall thing isn't working for me. What else can I do? And a lot of those people who chose in similar directions ended up being called Agile. How else can we understand Agile? Well, Agile is originally understood, and a lot of Agile practitioners these days are rejecting this approach to Agile. But those of us who've been in it for a while find that Agile is a really effective umbrella term. Once upon a time, there was some dude, Alistair Coburn, hanging out trying to solve projects, and he found that the people doing these waterfall approaches were being very silly. They said that we should have a software methodology and we should follow it. And Alistair, early 90s, says, you know, it seems to me that the best methodology to handle a 3-person, 3-week project might not be the best methodology to handle a 100-person, 3-year project. Maybe we should look at the characteristics of a project in order to determine how best to manage a project. If you have 3 people in 3 weeks, the best method we have for managing the project is to get a room, put the 3 people in it, and close the door. When they're done, they will tell us. We don't need any more governance than that. And in fact, more governance than that will make the project worse and slower than if you just have a room with a closing door. If you get 100 people and a 3-year project and you do it that way, you're just confused. That's a horrible way to manage a 100-person project. And that was Alistair Coburn. He defined that approach to deciding what kind of governance to have based on features of the project. He called that Crystal. It's a fascinating approach. Later, up at Chrysler, a bunch of developers, really famous names, Kent Beck, who invented unit testing, basically, Ward Cunningham, who invented the wiki, Ron Jeffries, famous software author, a bunch of other folks. They got together and were doing a project at Chrysler and said, hey, this is the 90s, let's all be extreme and stuff, like extreme sports. So how about if there's a software practice that we know works, let's do it all the time. Let's turn it up to 11. If there's something that we know doesn't work usually, let's just skip it entirely. And so XP did things like, hey, if you're a software developer and you run into a problem, how do you solve your problem? Well, before there was Google and Stack Overflow, everybody in the software world solved the problem the same way. First you stare at it for a while, then you beat your head on the keyboard, and then when that doesn't work, you call your buddy over. The two of you sit down together and you write the code together while talking about it. That's simply the best way to solve hard software problems. And everybody who's ever been a developer knows this, right? This isn't news, it's not surprising, it's not tricky. If you want good code for hard problems especially, you sit together with somebody else and you solve it together. That's how you get better code. Turns out not only do you solve harder problems, but when I write code with somebody else, the code comes out better than when I write it by myself. So let's turn it up to 11. Let's, every time we write software together with somebody else, 2 people, 1 keyboard. Oh, okay. Well, that's a reasonable thing to do. If that's how all programmers solve their problems and it results in better code, why don't we just do that? Because that's not how we do things. Okay, so what? Turn it up to 11. We'll be extreme. Extreme Programming went through and gave a list of a dozen things we should do to make software projects good. 9 of those dozen are, how should the programmers do things differently? Down in Austin, different group of people hanging out, minding their own business, doing software projects, failing software projects, complaining that software projects failed. They said, hey, wait, software project management is a process management thing, isn't it? Why don't I go talk to some expert software process guys? And so some college up in the New Jersey area, they went up, talked to the guy, professor of chemical engineering focused on process management, and told him what their software process was, and he laughed at him. Said, yeah, man, that's a great way to solve one kind of process, but you have to understand there's 2 kinds of processes. Some processes work, right? You pour 3 chemicals together, you turn the temperature to 130 degrees, you come back in 3 days, chemicals are mixed. Some chemicals, you mix them together and you turn the temperature to 130 degrees, and 30 seconds later you check the temperature and you check the pressure because these chemicals don't react in predictable fashions. And so instead of setting a plan and following the plan, you have to do something different. You set a goal and you adjust all of the time to a point where a plan is just stupid. A goal is what we need, and plans are silly, and we adjust based on the current circumstances. We call those kinds of processes defined processes versus empirical processes. And so Scrum came up with a way of doing software development as an empirical process where big plans up front are considered really silly ideas that cannot possibly work. And we adapt. Scrum is 95% about project management and very little about other stuff. So we've got Crystal, which is about how to decide what kind of governance to do. You've got XP, which is about how do you do the developers. You've got Scrum, which is project management. You've got Kanban, which is a process improvement methodology borrowed from Japanese manufacturing. We have Lean, which is a bigger chunk of the Japanese manufacturing philosophy. You've got Dynamic Systems Development Method, which is an offshoot of the Prince 2 approach in Great Britain, and on and on and on. And later, recently, you've got stuff like SAFe, Scaled Agile Framework. There's a bunch of different folks who have been going about solving problems in the Agile space, and each one of these folks comes up with a way of solving a problem or 2 or 5, but very few of these are actually going to say very much about how one another work, right? Kanban's mostly a project improvement methodology. Scrum is mostly a defined process. Really, there's very little in conflict between Scrum and Kanban, even though they both focus on process. XP focuses on development and has almost zero conflict with Scrum. Crystal is about choosing methodologies based on project features and doesn't conflict with anything here. SAFe talks about how to deal with large projects that need multi-level scaling. How do you coordinate large groups of people? Okay, well, Agile is a term that means approaches like these ones. When I understand Agile, I tend to look at it from the point of view of, hey, it's an umbrella term that means all of these. Some other people, when they approach Agile, approach it from the point of view of, here's the manifesto. The Agile means the manifesto. It's not my personal preference to approach things this way, but a lot of people do. Hey, here is how we should do things. There is value in the items on the right, but the value on the left side is generally more for the kinds of projects we do. So this means that while processes and tools are valuable, focus on the individuals and interactions first and let the processes and tools come. While comprehensive documentation is useful, working software is more useful. This is a list of what happened when the people from all of these groups got together and said, what can we all agree on? They came up with this, and then they have principles to follow this saying, hey, here's what we've got, and there's a bunch of these that are interesting. Hey, don't do work that you don't have to do work at. No death marches, right? And there's a bunch of principles here. The Agile Manifesto principles are very nice. A lot of people who focus on Agile, who spent the last 5 or 10 years doing Agile, sit with Agile Foundations here as the beginning of Agile, and they work off of these rather than off of the methods that got Agile going. And so they evaluate these methods on how Agile they are. It's an interesting approach. It's not Kyle's approach, but it is an interesting approach. Then you've got some folks, me, a few other folks I know, who look at Agile and go, oh, look, Agile, it's another system like these other ones. There's a class of systems that are complex adaptive systems or dynamic systems or such, where planning everything up front, planning a lot of stuff up front is impossible, right? Where the notion of building an early plan that can be right is a laughable thing. You cannot do it. And so, in all sorts of places, people have come up with and said, you know, there's probably a better way to do this or to understand things. And so in manufacturing in the 70s, Toyota and Taiichi Ohno took a bunch of principles that had come from the US rebuilding efforts in Japan through W. Edwards Deming and such, plus mixed in with some of his own brilliance, and built something called the Toyota production system, which is why an awful lot of cars on American roads today are Japanese, because they learned how to build cars differently and really well. The most common term when importing notions from the Toyota production system into the United States is lean manufacturing. Lean has a bunch of ideas about how to deal with uncertainty and lack of information up front, and they talk about how to do this in manufacturing. The military basically lost the air support war in Korea very badly and tried to figure out how to update so that their air combat would go better in the next conflict, which turned out to be Vietnam. The most interesting approach coming out of that was this fighter pilot named John Boyd, who codified his thinking into an approach called UDA. Says, observe, orient, decide, act. Every person who is making decisions in a combat situation is going through a process where they observe the situation, they orient, they get an understanding of the situation, they decide what to do, and then they do it. They have their OODA loop. Whereas historically we've thought about combat as being primarily about mass of force and how quickly and easily you can apply force somewhere, John Boyd said, you should really think about combat psychologically. And in Air Force, in air combat in particular, the question is, how quickly can you observe, orient, decide, and act versus how quickly can your opponent? If you can do observe, orient, decide, act faster than your opponent can get through their cycle, particularly if you can do it substantially faster, then they never even get to their action component. You observe, orient, decide, act. They see your action, they observe your action, they orient on what you're doing, they start to decide. If you act again before they get to their action point, the battle's over. They can't keep up with the speed at which you're changing, and so you just win. He wasn't well appreciated by the Air Force, partly because he was a colossal jerk, but modern Marines doctrine comes massively from John Boyd's thinking. His OODA cycle is a major part of this, and he was doing this in the 50s. Do we need planning to get a variety of organisms on the world today? No. Darwin in the 1800s was talking about how evolution, a lack of central planning and a lot of experimentation is the way to get stuff to work. How do planned economies work as opposed to dynamic economies? Well, there was a lot of talk about how they might be better, but Friedrich Hayek pointed out why it is impossible for a planned economy to be competitive with a dynamic adjusting economy. And the use of knowledge in society, of course, is the best paper on that. And that strain of thinking is there as well. And then modern US startup culture is, again, try and see based approaches as opposed to early decision, follow the plan based approaches. The Lean Startup might be the best single book on that point. So what we have is all of these different systems all pointing in the same direction. Basically, how do you deal with changing complex systems? Agile is the approach in software for dynamic stuff. I say there's 3 different approaches. Hero is an approach where we solve today's problem quickly based on expertise, interrupting who needs to be interrupted, and independence. Waterfall solves a different problem. We are going to plan everything, we are going to schedule everything, we are going to manage everything, and it solves project level problems, particularly on large projects, and it coordinates. The problem Waterfall solves is how do you coordinate a lot of group people together. Agile says, how do you handle change across the lifespan of a product? Instead of when a project ends, a software should be considered from the beginning of its lifespan to the end of its lifespan. And if you're going to do that, then feedback, focus, and collaboration is the approach that will get you a solution. And if you want to understand Agile deeper, start from the position, I'm wrong a lot. I'm going to build a design, but I'm wrong a lot, so what can I do to make it so that when I find out what's wrong with my design, I can handle it? I'm going to solve a problem in software, but I'm wrong a lot, so how can I make sure there's other people involved to catch me being wrong early? Agile's approach, I have found easiest to understand as a feedback, focus, and collaboration-centric approach. Focus meaning Agile says what's most important, let's do that one. Let's not schedule everything. Let's do the most important thing first. When we get done with the most important thing, we'll do the next one. I'm going to be wrong. Let's respond to the new information. Let's actively collect information about where I'm going to be wrong early so that I can respond to it. Let's not rely on a single hero solving problems because everybody's wrong a lot. Let's work in a team-centric fashion, including the manager's wrong a lot, so more decisions need to be team decisions. So one of the things Agile does, along with Lean, is focus on visibility. Predictability is an interesting question. In software, we find out that being predictable is hard. We make an estimate, we're wrong a lot. Agile's heavily into adaptation, and it's a good way of solving problems where change is the issue. If you have bad projects, we run into issues. Much of the time, if you look at okay, this is a great question. I'm sorry I just didn't see it. Is Agile going to replace both Waterfall and Hero? No. My experience says that there's a lot of people who don't understand Agile at depth who want to use Agile to solve all of the problems. My experience says that Hero and Waterfall both are very useful for specific things. However, the question comes in, how likely is it that your primary problem in software, in a given business software problem that you have, is how do I deal with these new changes, as opposed to how do I get this out yesterday, or how do I coordinate this 100 people working together? As I watch software over the last 20 years, I have seen a drift where more and more of my problems are how do I handle the change, and fewer of the problems are how do I coordinate everybody, or how do I get this fix out in the next half hour. If you need a fix out in the next half hour, call your hero. That is the right answer. If you need to coordinate 100 people for several years, do Waterfall. It's the right answer. But fewer and fewer of the problems I run into are either of those other problems. More and more of the problems are, how do I build software systems that are change resilient when the requirements are going to change and the customer is going to change their mind and my target market's going to change? How do I do that? That's the problem Agile's built to solve. And I'm finding most of my problems look like that now. I completely support Hero and Waterfall for other approaches, for other problems, but I'm just not seeing the other problems very often anymore. Did that answer the question, Rajiv? The question was, is Agile going to replace Hero and Waterfall? My answer is no. though more and more things are appropriate to Agile these days. Agile project success, a lot of what people understand about Agile comes down to, hey, we want to deliver incrementally so that we can get feedback systems. We want to demo to customers what we've got working frequently so that we can get feedback systems. And we need to keep improving our process because doing external feedback but not internal feedback is silly. Agile's heavily focused on stable teams. It tends to improve team morale and do less turnover. It also tends to result in more of what the customer wants because we're talking to the customer a lot. There's a lot of examples, case studies going on. I've been through several Agile transformations. I've done training at several other places doing Agile transformations. Time to market's a really big deal. Early prototyping's a really big deal. These are things that you do with various kinds of Agile. Defect reduction is potentially handled. Teams tend to work better. Most of what people do in an Agile coaching world is work on making teams work better. And so, I'm sorry, my mouse is misbehaving. So I'm not going to push on this. 80% of projects will be managed using Agile by 2018. I don't believe that. A lot of projects are using Agile, but a lot of people are kind of adopting Agile and finding out that doing quarter adoptions of Agile is a bad idea. And I agree, if you're going to do Agile projects, take the Agile Foundations seriously. And so what does Agile look like? Well, again, I'm going to use my approach instead. When I talk about Agile, the other thing I talk about is very few people know what I'm talking about. Most people when they say Agile in 2004 to 2014, they say, oh, Agile, you mean Scrum. Well, Scrum is part of Agile, and it's focused on the project management side of Agile, though preferably not in projects. If you talk to most people who are buying Agile, they're looking for a different approach to project management. If you talk to most people who are working as Agile coaches, they are most interested in the team improvement side of Agile. And probably 80% of the work done by most Agile coaches is making the teams work better as teams. Agile's about fast cycles and feedback systems. That completely changes the job of the product manager, whose job is to say, here's what we need the system to do. Whereas before it was a part-time job that somebody could do easily. Product management, it completely changes under Agile. It's taking the business analyst approach and completely taking it apart. It's probably the single hardest part of Agile and the least well understood. The Lean Startup gives hints in this direction. The Art of Business Value, the book, gives other hints in this direction, but Agile has changes at the project level, the team improvement level, and the product level. How do you do Agile in a large organization. Agile was originally developed for how small teams work. How can you make this work at an enterprise level? Well, one thing that everybody in the Agile community agrees upon is projects, funding your software as a series of projects has really bad incentives that work against the goals of Agile. What you should do is fund teams. You should fund product life cycle, and you should feed work to the teams and the product, not feed individuals to projects. If you do that, you get dramatically different results and incentives. Well, that's an enterprise level decision. Yes, it is. Suppose I'm doing Agile, I have 4 different groups who have to work together. How do I make that work? Well, that's an enterprise problem. Enterprise integration is a major part of modern Agile. SAFe is the biggest name here. I'm not a huge fan of SAFe, but it is a big name and it solves some really important problems. The technical side of Agile is also around, and it breaks down into 2 sections. If you say Agile, are we talking about DevOps kind of Agile, where we're changing how we do the builds, the deploys, environment management section of work, right? Because that stuff is an entirely different thing. If I want to be able to change my software quickly, it doesn't matter how quick I want to change my software if I have a 6-week deployment pipeline. You have to change the build, deploy process, and even the governance at the enterprise level here. And then there's the practices that we started doing back in the early 90s in XP, in which we basically said, how do developers work differently? The business of writing code, I honestly don't care how good your build pipeline is. I have seen software where, I've seen lots of software where what I think should take 1 day of work to make a change to the software takes 13 weeks of work for a whole team, right? I've honestly seen some software be 1,000 times as hard to change as other software. 95% of that 1,000 times as hard to change is how the software gets written. So you can do project management, team improvement, product management, enterprise integration, and DevOps, and you can still have bad software that you can't make changes to because your software won't support it. That's my primary focus in Agile, is on the technical side. Agile wants the ability to, if you talk about Agile, you're probably talking about some of those, maybe lots of those. Which of those? Well, it depends on who's talking Agile. If I'm talking Agile, I'm talking about all of these pieces. Most people who are coaching are talking about these layers. Most people trying to buy Agile are just talking about that layer. So those are the setup. There's also a question of how you do transitions. One of the reasons that we're seeing big work right now in Scrum side and on the SAFe side here is because SAFe is starting to push us in the Agile approach, but we're talking about transitions. In general, an Agile team should be a 2-pizza team. In general, you should not have teams in Agile working on multiple projects. You should have a team and bring work to the team. Teams should be cross-functional, not all the devs on this team and all the testers on that team. Teams should have some expert level knowledge, team members should have some expert level knowledge, and a lot of broad base. So if Bob the tester asks Chuck the developer to help, the developer will help. Collaborative, co-located, and such. This is Cotter's line on burning platform. How do you get a change to happen? This is also Cotter, build a powerful guiding coalition to make change. So for doing Agile transitions, this is straight up out of how you get these change to happen out of standard change management books like Cotter, and this Agile release train is from SAFE. Okay, that's what I wanted to say. I'm not going to talk about the other parts of this. Those are a specific theory of doing Agile that I'm not going to go into. Agile means a lot of different things to a lot of different folks. You can understand it from history as an umbrella term, just the manifesto, part of the lean, OODA, evolutionary approaches. You can understand it via underlying principles, feedback, focus, and collaboration in order to solve change problems. You can understand it as including project management, team improvement, product management, enterprise integration, DevOps, and tech Agile. That's what Agile is roughly about. That's my hour. Questions? Okay, it looks like we're having few questions. I've got an introduction to Agile for you. The next class, half an hour from now, is confirming this, is an introduction to DevOps. And it starts at 12:30 Eastern. Questions? Going once? I put the handout, the first presentation that I was working from, up on the slides, up on the handouts section. And I'm going to get out of here pretty quick since I'm getting no questions. Going once? Going twice? See some of you in half an hour.